needed extra help, you can look at that. I'm recording this one now. So this is 2.3. This is all on lines, linear equations, stuff dealing with lines, how to graph them, how to find out information about them. Hopefully I'll review, and hopefully you can just fill in these blanks. This is stuff that you did a lot of in Math 1010. Okay, the reason we start with lines is because they're the simplest and easiest, most basic type of graph. Okay, pretty easy to work with. It's hopefully easy to remember all this stuff. And if you're really good at working with lines, then you'll be better able to handle the more complicated graphs that we'll do a little bit later. Okay, so in general, this is what we need to be able to do. Okay, in a nutshell, this is the stuff that you've got to be able to do on lines. You've got to be able to graph a line from an equation. So if you're given an equation, you better be able to graph a line and find the equation of a line from a graph or information about the graph. So they might not give you a graph, but they might say, hey, here's a slope and a point that this goes through. Come up with the equation of the line or something like that. Now, please make sure you remember those two things and these next two things. This is really important. If you're going to write the equation of a line, you have to have two things. What are they? You got to have a point. Got to have a point. Got to have an x and a y. And you have to have a... Okay, 2 points would work, or more general, what did you say? Enough information. So they might give us 2 points so that we can find the slope, or they might give us another line and say, hey, make your line parallel to this one or perpendicular to this one or something like that. So you have to have a point and you've got to have a slope, or they've got to give you enough information to figure out what the slope is. So let's make sure that we're all clear on what slope is. Slope is always a fraction. Even if it's not written as a fraction, you want to think of it as a fraction. Slope is always a fraction, and it tells us a couple different things. It represents how steep the line is and in which direction it slants. Two things. The number represents how steep it is, okay, kind of like the absolute value of the number, okay, that'll tell us how steep it is. Okay, the sign of the slope tells us which direction it slants in. So there are 4 categories here, and it's usually best if we describe them by thinking about how we move from left to right. So if I'm going up from left to right, this is called a positive slope. If I'm going down from left to right, this is called a negative slope. What's in between positive and negative numbers? 0, okay? So this is 0 for a slope. Now, the way I like to describe this is, okay, if you were dropped on a mountain slope to go skiing or snowboarding or something, let's say you were hella skiing or whatever, you're dropped off right here. Is there something for you to land on? There is. So there's a number that represents how steep that is. If it's going up from left to right, we happen to use a positive number to represent that, okay? If we dropped off right here, is there something for us to land on? Yep, we'd have our little snowboard or our skis right here. There's something for us to land on, so there's a number that represents how steep that is. Okay, happens to be negative because we're going down from left to right. What if we're dropped out of a helicopter right here? And we're going to land on something, we can stand there, we're not going to slide right or left. Okay, so there's a number that represents how steep that is, and it's not steep at all, so that's 0. Okay, what happens if we got dropped off right here? We would die. Is there anything for us to land on? There's not. There's no slope. There's no number that represents how steep that is. So we say this is no slope. So again, if you think in terms of mountain slope, there's a slope here, there's a slope here, and there's a slope there. There is no slope for us to land on right there. We are going to be dead if we get dropped off there. Okay? Now, you can say that there's no slope, or we also use another word. We say that this is undefined. And again, that means there's no number that represents how steep that is. Okay? Now, there are a couple different ways that we can think of slope. There are a couple formulas. The first one is a little bit more graphic orientation. It's the rise over the run. And the rise is whether you go up or down, and the run is whether you go right or left. So if we were to write down, it is. Here, you'll need these. And then the roll's right there if you want to say. Okay? So rise over run, and then you'll need this formula right here. This is really important. Slope, if we're given 2 points, we can compute the slope, and what goes on the top of this? Y2 minus Y1. So this is the difference in the y's over the difference in the x's. Remember, we said the rise was how far we go up and down, and the run is how far we go right and left. Okay, there's the difference in the y's. Those are vertical coordinates, and there's the difference in the x's. Those are horizontal coordinates. Okay, so on the next one it says, and you've got some problems that are literally this simple, find the slope of the line that goes through those 2 points. Well, there are 2 ways to do this. One way, which I wouldn't really recommend, is let's go ahead and graph the points. So we could graph -4, 3, so there's the first point, and 6, -2. So 6 is over here and -2 is right there. Okay, here's the line that contains those 2 points, and then I could literally just count. I could figure out, hey, what's the rise and what's the run? So there's the rise. Notice we went down, so the rise would be negative. And we went from left to right, so the run would be positive. Okay, so the rise in this case, we're at 3, and we go all the way down to -2, so that'd be -5. And the run, we were at -4, and we go all the way to 6, so the run would be 10. So if I do the rise over the run, I get -5 over 10, so I'd reduce that, so -1/2. There's the fraction that represents how steep that line is and the direction it slants. Notice the negative, down from left to right. It's not very steep. The fraction's 1/2, so that's a pretty shallow slope there. Any questions? Okay, that's a bit of a pain in the butt because you've got to graph accurately, and if these points were really far apart, you'd have a lot of counting to do. It's a lot easier to just do it this way. Let's do y2 minus y1. So here's y2, -2. Write the minus and then go find out what y1 is. So that's a 3. x2, that's a 6. Write the minus because that's part of the formula, and then go find what x1 is. So that's a -4. So this is -5 over 10. Minus minus would be a plus here, right? So we get the same answer, -1/2. Okay, a lot better because you don't have to graph it. You're relying on an algebraic formula rather than drawing a picture, right, and counting, right? Any questions? Just decent review, right? Okay, so let's take a look at the next part. There are 3 main forms of a linear equation. This one is called slope-intercept form. This is probably most people's favorite because it's the first one you're introduced to. It's a nice graph-friendly form. This one is also really important, and if you don't like this one, I would get to know it pretty well. Okay, point-slope form is really nice because you don't have to have a specific point. On this one, you really do have a slope and you have a point. It's just that that point is a specific point. It's the y-intercept. In order to write this, you have to have the y-intercept. In order to write this, all you need is the slope, which you need for any linear equation, and any point. Doesn't make any difference whether it's the y-intercept or x-intercept. It could be in any quadrant. Doesn't make any difference as long as it's the right point on that line. Okay? And then this is called general form. We use this a lot when we're solving systems of equations and stuff like that. So you ought to just be familiar with those. In particular, this one right here. So it says, find the equation of a line that goes through the following points. Write your answer in slope-intercept form and point-slope form. So you'll notice that those points should look familiar. They're the one that we just did, aren't they? So the slope is -1/2. Now, we said in order to write the equation, you've got to have a point and a slope. Well, I've got 2 points to choose from, and since this is x1, y1, I'm going to choose that. Now, if I were doing this problem, okay, I like point-slope form. So I like y minus y1 equals mx minus x1. So I'm just going to plug those things in. Y minus, y1 is 3. The slope, that's -1/2. And x minus, write down the minus, then go find x1. That's going to be minus minus 4, so I'm going to write plus 4. That's the right answer. So we're done. If it said leave it in point-slope form, okay, that's just fine. It's in point-slope form. Done right there. If you want to put it in slope-intercept form, then we'd have to distribute through. So this would be, y minus 3. This is -1/2x, and -1/2 times 4 is, let's see, -2, And then all I need to do is move the 3 over to the other side. So I get y equals negative 1/2 x, and then plus 1, and that's the other answer. So point slope form here, slope intercept form here. If you like to plug into slope intercept form and find what the b is and then rewrite it, that's totally fine with me. Okay? Either way is fine. Any questions? Okay, let's take a look at the next one. Can you fill in those blanks? Y equals a number is a, what is it, Tylen? Horizontal. So if it's y equals 7, that's a horizontal line. If it's y equals negative 19/32, that's a horizontal line. If it's x equals a number, then that is a vertical line. Okay? And just for the heck of it, what's this number called, or what's this symbol called right here? Okay, it's called a pound sign. Okay, in our setting, it's called a number sign. And you probably know it as a hashtag. No? Really? Isn't that what they use on Twitter all the time? Okay, all right. In this setting, it has a lot of different uses. It's used as a number sign here. Okay? Now, people forget these simple ones all the time. They forget that if they have an equation with a plain old x or a plain old y and nothing else, that's going to be either a horizontal or vertical line. And they forget a lot of things that go along with that. Okay? So please don't be one of those students that sees one of these equations and says, oh crap, that doesn't look like slope-intercept form. What do I do with that? Okay? So we just want to quickly graph each one of these. So x equals a number. That is a vertical line. And this is a horizontal line. And I'm going to do 2 different colors here. So the vertical line, x equals 3. That means we go to 3 on the x-axis. And there's no condition on what y can be. All we have to do is make sure that x is 3. You can go as far up as you want or as far down as you want. So there's our vertical line of x equals 3. And then the only condition here is that y has to be negative 2. So if I go down to negative 2 on the y-axis, I can go as far to the right or the left as I want. So here is y equals negative 2. There's our horizontal line there. Now, what type of slope is this? Undefined or no slope. There's no number that represents how steep this is. What about this one? That's 0 slope. Okay, now if I were to take this and write it with a slope, this is what it would have to be. So there is our slope of 0 right there. Okay, so you can put that one into slope-intercept form if you had to. You can't do it with this one because there is no slope. Okay, any questions? Okay, and then you can fill in the next part, can't you? Parallel lines have slopes that are exactly the same. Okay, they're exactly the same. Okay, and perpendicular lines have slopes that are opposite reciprocals. Okay? Okay, so the next problem says, graph the line 3x minus 4y equals 8. Find the equation of the line that is parallel, and then find the equation of the line that's perpendicular and happens to go through those points right there. So I'm going to graph the line first of all. So we're going to take this, and I'm going to put this in a graph-friendly form. It's a little hard to tell what this looks like without rearranging this. So I'm going to write negative 4y equals negative 3x plus 8. I'm putting this in slope-intercept form. Divide by negative 4. So I get y equals, let's see, that'd be 3/4 and then minus 2. So the slope is 3/4, the slope is 3/4, the y-intercept is negative 2. So we're going to go here, and then I need to, let's see, this is a positive, so it's got to go up from left to right. It's going to look something like this. I rise 3 and run 4, so we're right there. I could do it again. And I could also go down 3 and back 4. It would look like this, but there's the line. Okay, there's the original line. So this is y equals 3/4 x minus 2. Any questions there? Okay, we want to find the equation of the line that's parallel to that goes through this particular point right here, 2, 2. So if their slope is 3/4, and I want a line that's going to be parallel to that, what does our slope need to be? Got to be 3/4. Okay? So I could do, I'm going to do this one a little bit different. I know that the slope is 3/4. What I don't know is what the y-intercept is. Now, I normally would plug into this. I'd put a 3/4 there. Oops, x1. And then I'd pick the x and y values to plug in here. I did that last time. I'm going to solve it this way. So I'm almost done. I almost have the right line. The only thing that I'm missing is the y-intercept. I've got this point right here. Remember, if this point is going to be on that line, it better make the equation true. But look how many variables I've got. I've got a y, an x, and a b. I don't know what the y-intercept is yet. But if I plug that x and that y in, I can figure out what b is. So this is 2 equals 3/4 times 2 plus b. So let's see, 2 equals, this is going to cancel here. So that's going to be 3/2 plus b, and then I'm going to subtract 3/2. So I get b equals, correct me if I'm wrong, but that's going to be 1/2. So that means my line is y equals 3/4 x plus 1/2. So it's going to cross at 1/2. That's a little bit of a pain. It's going to have a slope of 3/4. So I'm going to rise 1, 2, 3, and then go over 1, 2, 3, 4. So we're about right there. Now if I connect the two of those, even on my crappy graph, they look like they're parallel, right? Okay, now you should do at least one more just visual check. Does this look like it goes through 2, 2? Does it go through the right point? It sure looks like it does. Okay? Yeah.
Would we have to find the intercept, or could we just go to point 2, 2 and then do the slope?
You could do that, but then you wouldn't have the equation. If you wrote the equation like this, so this would be, if it said you could write it in point slope form, you could write that and then graph it from the point.
If it doesn't say move in one of the walk.
You're right. Yep. Good? Okay, Tylin brings up a good point. This is why if you were to go to another country, if you went to Europe or Asia, they normally don't teach this. They don't emphasize this. They show it, but they don't emphasize it. Because this right here, again, the nice thing is, hey, it goes through this point. Let's just go right there, and then let's just use our slope to produce another one. You don't have to have this special point on the y-axis. Okay? All right. Anything else? Okay. If it's perpendicular. So if their slope was 3/4 and we want ours to be perpendicular, what does our slope need to be? -4/3. So I am going to do this one in point slope form. So this is going to be y minus, here's y1. The slope is -4/3, and then this is going to be x minus, here's x1, there's a 4. Okay. Again, if they didn't say what form it had to be in, you could leave it like this. Okay, I'm going to go ahead and put it in slope-intercept form. So this is going to be y minus 1 equals, this would be -4/3 x. And if I multiply here, I get +16/3. And then all I have to do is move this to the other side. So I'm going to do that by adding 1. So this is going to be y equals -4/3 x. And then this is going to be plus 19/3, doing a little bit of fraction arithmetic there. Oops. Any questions? Okay, and again, can you see why point slope form has its advantages? That stinks. That's 6 1/3 for a y-intercept. So we've got to go up 1, 2, 3, 4, 5. 6 would be a route right here. 6 1/3 would be there. And then we've got to have a slope of -4/3. So down 4, there's 1, 2, 3, 4, and then over 3. So about right there. Do they look like they're perpendicular? They do. And does it go through the right point? Sure looks like it does. There's 4, 1 right there. Okay? Any questions? Sure? Okay. Last couple then. Find the equation of the line based on the given information. Should be easy, right? Does it specify which form? Nope. So let's do both. On this one, we're going to do y minus y1. So what do I write?
Y
Plus 1. Slope is negative 2/3. X minus x1 is 1. Okay, there it is in point slope form. If it said write it in point slope form, then you'd be done right there. Let's go ahead and write it in slope intercept form. So this is going to be y plus 1, negative 2/3. So if I subtract 1 from here and here, I get y equals negative 2/3 x, and then this would be minus 1/3, and we'd be finished right there. Let's see, did I make a mistake? This is a plus 1, right? If I distribute through, so that's negative 2/3, and that would be positive 2/3, is that right? And then to move the 1 over, I need to add 1 to both sides, so these would cancel, leaving a y here. And then I've got 2/3 minus 1, so 2/3 minus 1 is negative 1/3. You okay there? Got it? Okay. Any questions? Okay, would you do the next one, please? Okay, I suspect you're either on the right track or you're not. So let me come up here, and I want you to put your pencil down for just a second, and I want you to think about this. Okay, this line right here has a slope of 0, right? Okay, that's a horizontal line. The slope is 0. But we said slope was a fraction, right? Is that a fraction? Can you make it a fraction? Put it over 1, right? Now, we said perpendicular lines have slopes that are opposite reciprocals. What's the reciprocal of this? Puts a 0 on the bottom, right? Okay. Does not exist. No slope. So these are perpendicular to each other. Parallel or horizontal and vertical are perpendicular to each other. So on this problem right here, if this is a vertical line, which has no slope, perpendicular to vertical would be horizontal. Horizontal would have 0 for a slope, and we know it's got to be a horizontal line. Knowing that it's a vertical line, you know it's got to be a horizontal line to be perpendicular, so you know it's got to be y equals a number. Now let's take a look at the point that it goes through. If it's going to be y equals a number, is it going to be the 2 or the 3? It's got to be the 3 because that's the y coordinate. So the answer here is y equals 3. Don't have to graph anything, just need to think about it for a second. If you needed to graph this and say, okay, I've got this line that's x equals 4, and I've got this that goes through 2, 3, so over 2 and up 3, and it's got to be perpendicular to it. It's got to be this line right here, and there's our y equals 3. Okay? All right, any questions? Okay, let's take a quick look at the last two. I copied these. These are either problems from your assignment or they're almost identical. It says find the slope and y-intercept. Is that not easy? Piece of cake, right? So let's just move this around. Negative 3y, negative 2x plus 6. So this is going to be y equals 2/3 x minus 2, right? So the slope is 2/3, the y-intercept is negative 2, and then easy to graph. Up 2 and over 3. Looks like that. Okay, and this one says find the intercepts and then graph. So graphing using intercepts is a good skill. So I'm going to just make a little XY table. And the nice thing about a linear equation is it's only going to cross them in one place. So we're looking for one x-intercept and one y-intercept. So if I plug in a 0 for the x, I'm finding the y-intercept. So that's going to be 5y equals 21. So that's going to be 21/5. Ugly, but we can still do that. And if I plug in a 0 for y, that's going to be 7x equals 21, so x equals 3. A lot nicer number to graph. So 3, 0. Again, there's the x-intercept. The y-intercept is 0, 21/5. 21/5 is a little bit more than 4, so 1, 2, 3, 4. So we're about right here. And all we have to do is connect those 2 points, throw arrows on the end, and then we're done. Okay? All easy, right? Okay, hopefully there are a couple things there, those details about parallel and perpendicular, especially when we're talking horizontal and vertical. And then again, this detail about, you've got to have a point and you've got to have the slope in order to make that. Doesn't matter whether you're going to use point slope form or slope intercept, still going to have those. Okay, any questions? Okay, you can go ahead and get started on the assignment then.